Okie dokie. Here is our linear equations word problems worksheet. Okay, so the first thing I want to get started out off with is some. So it starts out with slope intercept. So we're gonna go and get some keywords for slope intercept here. Okay, so I think I'm gonna go ahead and write. No, we're gonna write them up here. Okay, I'm gonna take this all the way off. All right. We're going to go and write them up top. So this is for type 1, which is going to be slope intercept. Okay, for slope intercept, I know my equation is y equals mx plus b. All right, that's my slope intercept equation. So for my slope, I know that is my m. So slope is my m. Okay, and then my y-intercept is b. My y-intercept is going to be b. Okay, so whenever we're talking about word problems, slope is going to be referred to in a couple of different ways. Okay, they might say that it's paired with a variable. Okay, so they could say paired with a variable. All right, they could say a rate. Okay, a rate. Okay, we know slope is the rate of change, so that should be a pretty good little indicator there. Okay, option number 3. Okay, usually when you see the word per. Okay, so for example, $3 per every one cookie. Okay, hopefully you're not paying $3 for a cookie, but we could say $3 for every one cookie, right? Per one cookie. All right, and the fourth one is going to be cost per, once again, that keyword, per item. Okay, which that goes back to our cookie example. $3 per one cookie. Okay, but it's not always necessarily going to be cost. All right, a lot of our examples will be cost, but it doesn't necessarily have to be cost. So if I think of a different example that's not cost, that would be per. So maybe we're talking about a tree growing, okay? Maybe it grows 5 inches per every year, okay? So that would not be cost, but it would be per. It grows 5 inches for every 1 year, okay? Per 1 year, all right? So those are a couple of key words. When I see those in word problems, I need to know that those are associated with slope, all right? For y-intercept, okay, we also have some. Y-intercept is going to be a constant. Okay, it's not going to change. All right, if it's a fee of some sort, all right, they're not going to tell you your fee today is, $10, but if you join the same gym, a year from now, that it should still be $10 unless they have to change their prices, but it should usually be constant, all right? So on B, it'll also be our y-intercept. Okay, we already know that. All right, B is our y-intercept. All right, so another thing it could be is a one-time fee. So like we talked about the gym, okay, maybe, they charge me $10 to start my gym membership. All right, that is a one-time fee. Okay, you can also see it called an initial or starting cost. Okay, an initial or starting cost. All right, those are a couple of different ways you can kind of see some of these words here. All right. So let's go ahead and jump into these word problems. So the notes say use when given a rate of change, which is our M, and a starting point, which is our B. Okay, so a one-time fee is a starting point, and initial cost is our starting point. All right, So let's go and look at number 1. It says, Evan is going to the county fair this weekend. The admission to the fair is $5, okay? And the cost per ride is 50 cents. If his parents gave him $20, write and solve a linear equation to find how many rides he can go on. Okay, so I see an initial fee. Okay, in order to enter the fair, I have $5. Okay, so I'm going to go ahead and circle that $5. I'm going to write initial fee. And it says cost per, okay, 50 cents. All right, that is going to be my cost per ride. Cost per ride. Okay. So I have an initial fee and I have a cost per ride. So let's go ahead and talk about what our X and Y are even going to represent. Okay. So if it says the admission to the fair is $5 and the cost per ride, okay, if that's my slope, I know that my X has to go along with this. So it's cost per ride. Okay, when we talk about slope, we're going to kind of go back a little bit. I know that slope is change in Y all over change in X. Okay, so if it says cost per ride, I know that's telling me cost divided by the number of rides. So this tells me that my Y is cost, okay, and my X is the number of rides because it told me cost per ride. Okay, my Y goes on top, my X goes on bottom. All right, kind of an easy way to write your X and Y, what they represent. Okay, so now I'm going to go ahead and actually write an equation. So you can see that's already been done here for you. I know that this 50 cents is my M, and this initial fee is going to be my B there. So our equation is Y equals M, which is 50 cents, so 0.50, X, and then our y-intercept, which is our starting point, okay, our initial fee, which is going to be that $5. It costs $5 to even go into the county fair. All right, so now we have our equation written for this. But it asks us if his parents gave him $20, write and solve a linear equation to find how many rides he can go on. Okay, so if we're talking about $20, okay, that's going to be a cost. So now I've got to decide, am I going to replace Y with it or X? Okay, $20 is a cost. I go and look at what we did over here. Cost is my Y value. Okay, cost is my Y value. So I'm going to replace this Y value with 20, which you can see is done here. Okay, so instead of writing Y equals, I get 20 equals, because that 20 represents my cost, which is my Y variable. Okay, so now I've got to solve for X. All right, I can draw my line down and I've got to solve for X. So in order to move this plus 5 away from that, I've got to do the opposite, which is minus 5. Those then cancel out. I end up with 20 minus 5, which gives me 15. And over here, I'm left with 0.50x. Okay, this is a two-step equation, so now I've got one step left and I am done. So I have 0.50, okay, times x. So I've got to divide by 50 cents on each side. Okay, these now cancel out. I now have x all by itself. So x is going to equal, okay, if you plugged, and I'll go ahead and show it, if you plugged 15 divided by 0.5 in your calculator, you would get 30. Okay, but we're talking about a word problem here. So x equals 30 means nothing to me. 30 what? 30 elephants? 30 shoes? 30 pencils? I have no clue, okay? So what does this 30 represent? So if I go and look back at our little cheat sheet, is what I'll call it over here, okay? My x was the number of rides. So if x equals 30 and we're talking about x, it's going to be my number of rides. So x is going to equal 30 rides. So this tells me that Evan can go on 30 rides. All right. We're going to go and work through number 2 together for the slope-intercept. All right. So on number 2, it says, while visiting Crimson Lake, Sally decided to go kayaking. The rangers charge $8.50 per hour in addition to a $25 deposit to rent the kayak. If she rented the kayak from 11:30 a.m. until 2:30 p.m., write and solve a linear equation to find the total cost to rent the kayak. Okay? So what I have here, okay, is I have $8.50 per hour. So if I go and work with my variables over here, I have m equals change in y over change in x. So it says $8.50 per hour. So $8.50 is going to be a cost, similar to before, is going to be a cost. When it says per, I know that's slope, so I'm going to divide by the number of hours. So number of hours. So now I've broken down what my slope even means. So this $8.50 per, because remember per is the key word there, hour. Okay, so it's the cost per number of hours. So now let's go ahead and break that down further. So we said this is going to be our M here. And then it says a $25 deposit. Okay, if you're depositing something, that's going to be the same thing as a one-time fee. A deposit is a one-time fee. It is an initial cost to do something. Okay, so this 25 is going to be a one-time cost, so therefore it is going to be my B. So M is going to be $8.50, and my B is going to be 25. All right. I can do 0, 0 if that helps. $25. All right, so now I have my M and now I have my B. Now I've just got to write an equation. I know my equation is y equals mx plus b. So I plug in what I have. I get y equals, my M was $8.50. I write my x, and then I write my b. Okay, I owe $25 from the get-go. That's part of the cost I have to pay. So plus $25. All right, this question, I'm going to go and read it again. It says, if she ran the kayak from 11:30 a.m. until 2:30 p.m., write and solve a linear equation to find the total cost to rent the kayak. So on this one, it's talking about 11:30 a.m. until 2:30 p.m. All right, so let's figure out what that even means. So if I start at 11:30 a.m., okay, I know if I go down an hour, it would be, or go up an hour, it would be 12:30 p.m. because I've passed noon. Then I go to 1:30 p.m. and then I go to 2:30 p.m. So this is where, these are my two starting points, 11:30 to 2:30. I've got to figure out how many hours went by between then. Okay, so to go from 11 to 12, that was 1. To go from 12 to 1, that was 2. Or sorry, 12:30 to 1:30. To go from 1:30 to 2:30, that was 3 hours. Okay. So now I know that it's 3 hours. So now I've got to figure out where in the world in my equation do I plug this in. Okay, so we're talking about number of hours. We know that is 3 hours. So I go and look back at my little cheat sheet over here. So number of hours is what's on bottom of my fraction. I go and look up here. X is what's on the bottom of my fraction in my denominator. So number of hours is going to be X. So last time we replaced the Y. This time, because we're talking about the number of hours. All right, sorry guys, it cut out there. All right, so what I was saying is that we found 3 hours, okay? So the hours is going to represent our X there. So that's what we're going to replace in our equation. So instead of writing X this time, now we're going to replace it with 3 hours. So I have y equals 8.50. In parentheses, I'm going to put my 3. I'm replacing that with x plus 25. Okay, so now I go to my calculator. I have 8.50 parentheses 3 to represent my 3 hours plus $25 there. Okay, so what this tells me is it tells me that in order to rent the kayak for 3 hours, their total cost, okay, Sally's total cost is going to be $50.50. All right, so y is going to equal $50.50. Okay, and the reason I know that it's $50.50 is because if I go look over here, cost is my y value. Okay, so it must be $50.50. All right. Make sure you're using these variables to help you out there. All right. So those are my two slope-intercept problems examples. All right. You have one that's solving for x, one that's solving for y. Okay. I want you to try 3 and 4 on your own. Okay. 3 and 4 on your own. All right. You can check with a teacher when you are done. We should always have the answers. All right. So now let's go ahead and talk about standard form. Okay, standard form isn't something we've really talked about much, but it is something that we will use. Okay, so when we're talking about standard form, we're going to have ax plus by equals c. Okay, so I have ax plus by equals c. When I have standard form, A, B, and C are all constants. Okay, A, B, and C are all constants. What that tells me, okay, is that the numbers aren't going to change, okay? So they're all constants. It's going to stay the same. So let's go ahead and talk about what that means. So our notes say use when the problem relates to 2 different objects. So if we look at number 5, it says Sam ordered 2 hamburgers and 3 hot dogs. Okay, I'm comparing 2 different objects. All right, the number of hamburgers Sam ordered isn't going to change. That 2 is going to stay the same. He ordered 3 hot dogs. He ordered 3. That's not going to change. That's a constant. All right. Then it says from the concession stand at the baseball game, his bill came to $19.05. Once again, that's a constant. Okay, they're not going to tell him 10 minutes later that, hey, your bill's actually $21.50. No, his bill is $19.05. All right, that's a constant. It says if hamburgers cost $5.25 each, write and solve a linear equation to find the cost of each hot dog. Okay, so what we've done here is we've said that x is going to represent the number of hamburgers. Okay, and y is going to represent the number of hot dogs. Okay, the equation here is already set up for you. Sam bought 2 hamburgers, so I would have 2 of x. So we wrote 2x. Then go look at the next piece. It's 3 hot dogs. Okay, I go and look. Hot dogs is represented by y, so I have 3y. All right, which you can see right there. Then my total, okay, my cost, which happens to work out because since it's C here, totally works out pretty amazingly. My total cost is going to be $19.05. All right, it's my last constant. All of this added up together is going to equal my total cost. All right, then it says if hamburgers cost $5.25 each. So hamburgers, we said, represents X. So where we have x, we're going to replace that is what I meant to say. We're going to replace that x with $5.25, which you can see has been done here. Okay, so instead of writing x again, they wrote $5.25. Okay, now we've got to solve for this. All right, so to get started out with, I'm going to simplify this first piece. I have 2 times 5.25. which is going to equal 10.5. So I'm going to rewrite this. I have 10.5, so $10.50 plus 3y equals $19.05. Okay, so So now I'm solving for y. That's the only variable I can even solve for here. So in order to solve for y, I've got to move this 1050 away from it. Right now it's a positive 1050. So I'm going to do the opposite, and I'm going to subtract. And what I do to one side, I have to do to the other. So these ones cancel out. So when I'm solving this, I get 3y equals, okay, I have 1905 minus 1050. All right, which gives me $8.55. All right, now I have 3 times y. In order to get rid of that multiplication, I now have to divide. All right, so I divide by 3 on each side. So y is going to equal, okay, I do 8.55 divided by 3. So this now tells me that every single one of these is going to be, what was it, $2.85. Okay, so now let's talk about this a little bit further just so we know what we're talking about. Y was our hot dogs. So every single hot dog is going to cost $2.85. All right, because we accounted for how much we spent on hamburgers and we subtracted that from the total. Then we took our total and we divided that by 3 because I bought 3 hot dogs. So even without having to do all this, if you just kind of break down what it's talking about, you might be able to solve it without even going through the two-step equation. Okay? So just kind of think about what your problem is asking you. All right? We're going to go and turn to the next page now. Our next page, let me get it all set up here. All right. Here we go. So number 6 says tickets at a school play cost $4 in advance or $5 at the door. Okay, total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. All right, to find how many were sold at the door. So let's go ahead and break down our variables first. Okay, I know my equation, I'm going to go ahead and rewrite it at the top, is AX plus BY equals C. All right, so I've got to label something as X. So X is going to be, okay, what do we have first? The advance, all right, if they order or if they pay for them in advance. So my other variable I have is Y. So as opposed to buying them in advance, you could buy them at the door. Okay, so we could say that's going to be at the door. All right, now we've defined what our variables are going to represent. So now we've got to write an equation for this. It says $4 in advance. All right, so I know that 4 goes with that X that we just labeled. So I will write 4X. Okay. Then it says $5 at the door. So at the door, we just said was equal to Y. So it's going to be 5Y. So I write plus 5Y. All right, $4 in advance, $5 at the door. All right, we're just using our variables we've written and the information given to us. Then it says total ticket sales were $440. So I'm going to write equals $440. All right, now from here it says if no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. Okay, it says no tickets were sold in advance. So if no tickets were sold, that means that 0 tickets were sold. Okay, so if it's talking about advance, I go and look at my little cheat sheet key over here. We said that advance is equal to X. So where my X is, I'm not going to replace that with 0 because it says we didn't sell any tickets in advance. So I will write 4 times 0 because I replaced that X plus 5Y equals 440. Okay, because we're going to find how many tickets were sold at the door. We're solving for y now, which is at the door. All right, this is one of Coach Wood's favorite problems in the world because anytime you multiply by 0, it is 0, so it goes away. Okay, I love it when we multiply by 0 because I just get to cancel it out. So now I have 5y equals 440. So 5y equals 440. All right, now I've got to go ahead and solve this. I have 5 times y. So when I have multiplication, I know I've got to do the opposite, which is going to be division. So instead of multiplying by 5, I'm now going to divide each side by 5. Okay, so I get y equals, I now have 440 divided by 5. Okay, which gave us 88. Okay, once again, is this 88 llamas? Is it 88 pencil sharpeners? Is it 88 Scantrons? I have no freaking clue what it is if we don't label it. Okay, so I go and look at my y. Okay, we said it was at the door. Okay, so it's tickets sold at the door. There we go. 88 tickets sold at the door. All right. So now you'll try 7 and you'll try number 8. Okay. Try number 7 and try number 8. All right. We've got 2 more examples to go through and we will be done. All right. So we're going to go ahead and go down to the bottom here. On point slope. I know my equation for point slope is going to be y minus y1 equals m in parentheses x minus x1. All right, that is my point slope equation. All right, the notes say, use when the problem gives a sample point of x, y, and a rate of change, which is m. Okay, so let's go and look at number 9. Number 9 says, at Eagle Bay, it costs $12 per hour. So I know per means slope, which is going to be our m, to rent a canoe. Nate and his friends rented a canoe for 4 hours and paid $68. Okay, 4 hours and they paid $68. Write and solve a linear equation to find the cost to rent the canoe for 7 hours. All right, so we've got to go ahead and figure this out. My favorite thing to do to start out with is to break down what it gave us for our slope. So I know that once again, slope is change over y, or sorry, change of y over change of x, all right? So it said $12 per hour. So that $12 is a cost, okay, per hour. So it's going to be the cost over the number of hours. Okay, same thing we had previously on a different problem. Oops, sorry, I didn't realize I was off the screen. All right, same thing we had previously. So now let's keep breaking down the information it gave us. So it gave us the slope is 12. That's written down already. Now it said 4 hours and paid $68. So we know that number of hours is our x. So our 4 goes into our x place there. The $68 we said was our y value. The cost was our y value. So that's going to be our 68 there. So now we have a point, which we can label as x1, y1. I now have a slope, I now have an x1, and I now have a y1. So I'm going to go ahead and write our original equation here just so we can kind of compare it. Okay, so I leave the y minus, then my y1 was 68, so that's what we plugged in, equals our slope, which we said was 12. Then we have parentheses x minus, and our x1 was 4, so that got plugged in there. Okay, but we're not done yet because the question says write and solve a linear equation to find the cost. So it says the cost for 7 hours. All right, the cost for 7 hours. All right, so I need to go ahead and figure out what my cost is going to be for 7 hours. All right. So that 7 hours is going to represent our number of hours, which is going to represent our x value. So I'm going to take this equation I have here and replace our x value, because that's number of hours, with that 7. So I'm going to rewrite this. Here we go. I have y minus 68 equals 12, parentheses, I plug in a 7 for x, minus 4. Okay. Replace that x with the number of hours our problem gives us, which is that 7. So now I've just got to start breaking this down. So I have y minus 68 equals, okay, I have 7 minus 4. 7 minus 4 is going to give me 3. So I get 12 times 3. All right, I got to keep going with this. So I have y minus 68 equals 12 times 3 is going to give me 36. Okay, so I'm going to say equals 36. Now I've got this down to a one-step equation. All right, I have y minus 68. So instead of subtracting 68, which is what it gives us, I'm going to do the opposite, which means I'm going to add 68 to each side. These cancel out. So I get y equals, okay, I can plug that into my calculator if you need to. Okay, so I get 36 plus 68, which is going to give me 104. All right. So I'm going to go ahead and write 104. So now let's talk about it. What in the world does this 104 represent? Okay, I know it is a y value because we solved for y. So I go and check. I've got change in y, which is in my numerator at the top part of my fraction. So I go and check over here. Cost is my numerator, which is my top part of my fraction. So my change in y is going to be the cost. So cost is going to be in dollars. So this tells me that Nate and his friends, in order to canoe, all right, for 7 hours, they're going to have to pay $104. All right. So if they wanted to rent it for 7 hours, it would cost $104. All right, we're going to go and do one more example, and we will be good. Okay. So 10 says a construction company charges $18 per hour, once again per, for debris removal, plus a one-time fee for the use of the trash dumpster. The total fee for 8 hours of service was $219. Write and solve a linear equation to find the one-time fee for the trash dumpster. Okay, so let's go ahead and break down the information given. It says $18 per hour. So I know that is going to be my slope there. So M is going to equal $18. Okay, now I'm going to break down my slope. Once again, we know that slope is change in y over change in x. Okay, it says $18, which is a cost per, with that line, okay, and it says hours, so it's the number of hours. So we're talking about the cost per number of hours. All right, we've now broken down our slope. Okay, now let's go ahead and talk about the other piece of information it gives us. It says the total fee for 8 hours of service was $219. So 8 hours is going to be on bottom here. Hours is on bottom, so that means it's going to represent our x value. So when I write this coordinate, okay, this 8 hours, because it's my x value, is going to go in the x coordinate place. Okay, my 219, that's cost. And if I look on top, all right, it's going to be my change in y. So it's going to go in my y value place. All right. Breaking down the information given. So I now have a slope. I now have a point. I can now do point-slope equation. So I label this x1, y1. I go ahead and write my original equation just so I can always compare it. All right, good habit to get into. So I have y minus, okay, my y1, which is 219, equals my m, which we said was 18. And then for my parentheses, I have x minus my x1, which is 8 here. Okay, I'm just plugging in that information that I have. Now we've got to go ahead and move forward with this. Okay. It says write and solve a linear equation to find the one-time fee for the trash dumpster. All right. So we are assuming that we haven't used any hours. Okay. We're not even worried about, okay, the hours that we're using. All right, we are just going to be worried about the cost for the removal. All right. Okay, iPad's working again. Sorry, guys. Okay, so it's talking about $18 per hour, okay, plus the one-time fee. If I'm just looking for the cost of the one-time fee, I don't have to worry about the hours spent at all. Okay, so if I don't have to worry about the hours spent, I'm going to say we're at 0, okay, because I'm just trying to figure out what the fee is. And if I include any hours, that's not going to give me an accurate number there. It's not going to give me accurate information. So I'm going to assume that we've done 0 hours. That way I can just figure out what the fee is. Okay, that way that $18 per hour isn't included in there at all. All right, so my 0, okay, is going to be my number of hours. So I come and look, my number of hours is on bottom. That's on bottom here, which is my x value. So I'm going to go plug in a 0 for my x value. So I get y minus 219 equals 18 parentheses 0 minus 8. All right. So I've got to continue to break this down. I get y minus 219 equals 18 times 0 minus 8 is going to be negative 8 there. Okay, now I've got to keep going with this. I have 18 times negative 8. So I end up getting y minus 219 equals negative 144. Okay, now I've got it down to my one-step equation. So I have y minus 219. So in order to get that y by itself, I've got to remove that 219. Okay, in order to do that, I'm going to add 219. Bam, gone. Okay, so I do negative 144 plus 219. So I end up getting y equals 75. Okay, once again, we've got to figure out what in the world that 75 means. Okay, so I go and look at my y value. Y is what's on my numerator. It's on top. I come and look over here at my cheat sheet. It's cost. Okay, so this is going to be $75. So let's talk about what that means. So if, okay, I didn't remove any debris, okay, I did it for 0 hours, okay, I haven't even done that yet. If I'm just finding my one-time fee, I've now found it for $75. Okay, if I would have put 3 hours in here, okay, I would have gotten this fee plus 3 hours worth. Okay, so that wouldn't have been accurate. So in order to just find the fee, I need to do 0 there. 0 hours because I'm just looking for the fee. Okay, not including that $18 per hour. All right, so we end up getting y equals $75 there. All right, let's go and turn to the next page. So on this next page, we have number 11 and 12, okay? 11 and 12, those are both our point slope problems. So you should be able to work through both of those now, okay? On type 4, okay, it says 2 points. It says use when the problem gives 2 sample points, x, y, x, and y. Okay, so I know this would be x1, y1, x2, and y2. Okay, so here's a good example of that. You can see that the points have already been labeled, or sorry, have already been written. So then from there, you just have to label them x1, y1, x2, y2. Okay, they use their slope formula first to find the slope. Then they took their point and their slope and wrote a point-slope equation. Okay. Then from there, what they would need to do, because it says to surf the internet for 15 minutes at an airport, it costs $4.05. For 40 minutes, it costs $5. And, ooh, we messed this up. That should be 80. Let me correct this real quick. 580 minus 405. I didn't catch that till now. Okay, there we go. Now we got it. Okay. One part was just written incorrectly. There we go. Okay, so now we have our point-slope form. Okay, it says write and solve a linear equation to find the cost for surfing the web for 1 hour. Okay, so if I'm going to use this, I know that it says 15 minutes in airport, it's how much the cost is for 1 hour. So once again, I go M equals change in Y over change in X. I know that it's cost for a number of hours. For 1 hour, which is going to be, and all of this is based on minutes. So I've got 15 minutes, 40 minutes. So I'm going to do number of minutes. All right. So now what I would have to do, now that I have it in point slope, I know that my 1 hour would be 60 minutes. So my minutes is on bottom. So my X value is what I replace. So I'd write Y minus 4.05 equals 0.07. Instead of writing X, I'm going to write my 60 because that's what's going to represent my number of minutes, my X. Okay, and then from there, let's just go ahead and finish this one out real quick. All right, I wasn't planning on going over this one, but it's a good one to go over, so I'm not too worried about it. All right, so here we go. I have 60 minus 15, which is going to give me 45. Sorry, I meant to show that for you guys. Okay, so I get Y minus $4.05 equals 0.07. In parentheses, I now have 60 minus 15, which was 45. Okay, I've got to keep breaking that down. Y minus 405 equals, I have 0.07 times 45, which now gives me 315. Now I've got my one-step equation. We are almost done. Since I have subtracting $4.05, I'm going to do the opposite, which is going to be to add $4.05. Bam, goes away. So Y is going to equal 315 plus 405, okay, which is going to give me $7.20. Okay, once again, I'm going to go back and check with my slope we wrote to make sure what this unit is. Okay, I already said it was dollars, but let's just go ahead and check it. So my Y is my numerator, what's on top of my fraction. I come and check over here. Cost is what's in my numerator, which is at the top of my fraction. So Y is going to represent the cost. So this Y that we just solved for is going to represent the cost. All right. So that is how you would solve a 2 points problem. All right. First, you find the slope. Then I plug it into point slope. And then I've got to plug in the condition it's asking me for. So here it was asking the cost for 1 hour. And I knew that the 1 hour was 60 minutes. All right, so that's what we plugged in there. All right, so there's one example of 2 points. You could solve 14, 15, and 16, which is on the next page. All right, so 14, 15, and 16. It would be awesome if you made it through 16, but what I don't need you to worry about is this bottom part, 17, 18, 19, and 20. If you would like to try them, that's fine. They are in the teacher's journal, so you can check your work. But you do not have to solve 17, 18, 19, and 20. All right?